pleasure to introduce our next speaker, Anthony Nadeau, who will be talking about his work on a data access system.
Yes, a minimalist data access system. So my name is Anthony Nadeau. My professor is, or my advisor is Professor Jalate, and I'm presenting my capstone titled Coexist, a minimalist data access system. Hopefully the name will make more sense by the time we get to about halfway through the presentation. But I'll start by talking a little bit about who this project targets and what they do. What the problems I saw with their domain was, how I solve those problems. Then I'll hopefully show you a little bit about how the application works. Targeted at programmers, by the way, so if anyone wants to use it afterwards, it'd be a good chance to put on the spot. But so starting with who this is for. Coexist targets programmers who focus on a small subset of applications that deal with data storage. So of all the applications in the world, there's a subset of those in green called database applications. And you can think of those as any application that involves a database in any form. Actually, we've seen some today. I think Brian would be a good example of one that involves a database, if that's accurate. Within those applications, though, there's some things you can call data store applications. Perhaps you can call them data entry applications as well. They're things like, actually, the next slide gives you two examples of what would fall into this category. Something like a workout, a diet, an inventory application, or a weather monitoring application, which sounds a little vague. But on the left or on the right is the just a random Android application. There's tons of data applications you can find, and they all really fall in this category. When you download an application like this, you know exactly what it's going to do. If you would download a workout application, you're going to have to enter your sets, your reps, maybe some diet information. You really want it to store all that data for you, and you want to be able to get reports from it and something like that. So they're all the same for the most part. On the left-hand side is, I don't know if anyone here knows about the Melt project, who they monitor lake temperatures. They're with the university. But as part of a summer internship, we made this application for them, which is just like that workout application, except instead of doing sets of reps, you're monitoring things like intensity for light in lakes and temperatures in lakes. But the functionality across them is completely the same. So that really gets into the problem with the applications, as I saw it. They take a long time to make. The Melt project was a summer internship. It took about 2 months to make. Even though at the very start of it, we knew exactly what we had to do. We knew we had to have fields so they can enter lake readings, or something like the CSV files, the comma separated values that these applications give them, so they can upload those. But we still had to do 2 to 3 months to develop it. So that's where it gets into the redundant application development part, because those really do the exact same things, but we had to do 2 separate applications completely to create each one. Another problem with that was, say the Melt people wanted to have an Android client, not a web client, after the fact. We would have had to make a completely separate Android client that didn't use any of the web code at all, which is just more work to pile onto the whole process in the first place. And application development involves unnecessary coding. So that's a little subjective, but I think if you know exactly how to solve the problem and it's only a matter of time, then there might be a better way of solving the problem than having to just grind out all of that code in the first place. And that leads into what I think a good solution to this would be, in terms of reducing the amount of code that you would have to type. You have to make a new system of doing things. You can't do things the same way. You have to make a system where you make clients for other people, like an Android client, a web client, something like that, a desktop client, any kind of client you want. You make it for them. You make it configurable so they can use it without having to spend all the time I had to spend on something like Melt, or that other author had to spend on something like that workout application. You want to have clients for multiple platforms, which is really the same thing. You want to be able to remove the clients from the application so you can have these separate entities. Actually, that on there is the older way of doing things, not the Coexist way of doing things. That would be just a simple application, which would be like a website you visit with a database attached to it, and that is the client, that is the application. In Coexist, you want to kind of factor out some of the clients there. So you can have things like completely independent iOS, which is iPhone Android or web clients that all talk to the same server, that all update the same data on the database. And that also leads into having minimal development times. So you only have to require filling out configuration files instead of having to require creating all of these from scratch. Which seems silly because you have to do the exact same thing every single time, but you can't use any of the code you used before. So that ends up looking something like this. So you can't see any of that at all, but that's by design. That's the Android client for Coexist. It's about 4,000 lines of code. This is pretty much what you would have to write at a minimum to have a good functional Android client. It's actually deceivingly difficult to make a good Android client. You have to do everything pretty much, and Android isn't the, it's got a steep learning curve. So it's that, or in Coexist, you have your 3 files, which are icons that you want for your application. Because these are things that are supposed to be, in theory, factorable out of every application that you're going to create. So you have icons for your applications, and then using these, you can create, or you use an executable that I've made to create clients based on these things. Before we get into the details about how that actually works, we're going to talk a little bit about how clients communicate with the server, because that's really the whole change from the previous model, is that now there is a concept of clients. I do it through an API, which is an application programming interface, which is just a way for clients to talk to servers. These names were based on the things that clients need to do. If you're going to have one client that you write and everyone else actually uses, they need to be able to find out how do they display information to people, how do they store that data locally in Coexist. A big part of Coexist by design is replicating the database of the server entirely on the client. So every client carries a full copy of the database. Sync would be, how do I get missing stuff from the database? And create would be, how do I send things to the database? And using these 4 methods, if this bottom part was the client here, he would start off, or she would start off, on a meta model, getting UI information, getting database information, getting missing information from the server that they all share together, and creating information, and then coming back here and doing that over and over again. And this is pretty much the life cycle of an application that you'd like to be able to just create more quickly. And as an example, it seems weird talking about it when it's on a diagram like that, but this is a screenshot of a browser. You can go there in your browser, you can go to the server, you can enter the URL right there, and this is the kind of response you're going to get. In Coexist, there are JSON, that's a JavaScript object notation. It's kind of like XML, and if you don't know XML, it's kind of like HTML, although different functions there, but it's just one form of data exchange. It didn't really matter which one you used over another one. But we had to have something because you need a uniform way of having to have conversations with clients and servers. So I think that's a good point to start looking at the actual application. Now remember, this is for you if you're a programmer. This would be a really good thing to look into. But these screenshots here are what the code I'm about to show you will create. And this happens to be a workout log that I'm actually using. But it could be anything. Like we saw before, it could have been for lake readings. It could have been for medical data. It could have been for wherever you wanted to. So here we have the Android code, which is what you would have to write normally if you want an Android client. And I think a really good example of code you want to avoid writing would be database code, because there tends to be a lot of what they call boilerplate or setup code. Every single time you want to do anything, you have to make a connection, you have to make a statement, you have to prepare several things to that statement, you have to execute it, iterate through the entire thing, and it's 100% of the time you have to do that. You really don't want to have to do it every single time. You don't want to even have to do it more than once in a lifetime, but you have to. So that's Android, which is actually part of Coexist, which no one has to write anymore if they use Coexist. But this is the meat of Coexist, is these files. So you have your maybe I should open that up. That's okay. You have your parameters, basically, your key value pairs. And this is what you fill out when you use Coexist. You either say, I want Android to be built right now. I want a server client. I want to give it this name. I want to give it these images, which is what the icons were before. It's going to have this package name, which is an Android specific thing, because if you want to have multiple applications installed at once, then you have to have different package names. That's just how Android does it. You tell it where the server is located, which is where the database is located, or at least your interface as a client. You tell it a version number, a bunch of database credentials, and it gives you a client. Once you, there's a compilation process too. It's just one executable, but these are the three things that get built from that. You have your web code, you have your Android code, so you can install this on your phone, and then it turns into this. And then this lets you upload data, download data, get reports if you want reports, which is what the final one is actually. It corresponds in the end to a SQL view, if anyone cares to know. But that's how you would interact with it if you were actually using it as a developer. The two big parts of the project that I'm going to go into some detail about are database replication, which is how do you get everything from the server onto your client all the time. And from there, how does that look in a conversation between the client and the server, which is basically what's happening the entire time. So because it uses a database, which if you don't know, you can think of it as a bunch of spreadsheets that are related to each other, if that helps. You have to have some way of taking the contents of one database without using any other add-ons or any other dependencies, because that would really work against the whole purpose of Coexist in the first place. You're going to download all this other stuff and get it all configured to help you. And you have to find out how to get it back onto your client. So I decided to do that with timestamps. The timestamp column over here is updated every time one of these rows are updated. So in this case, Bob was updated 10 seconds after the creation of the database. They're just time since beginning in this example. And so is Dan. So if we had a client that only had Alice and Carol, the client would say, my most recent timestamp is 0. Give me everything I'm missing. It would say, okay, you're missing 10, you need Bob and Dan. And it sends these back. And that's the general way that it happens for all the conversations. And the next part ties that in with how it can be used in a more general example of Coexist. So this is a conversation between the client and the server. The client being on the left and the server being on the right. This is a request from the client to the server to that API sync method, which is one of those 4 methods that we saw before. This basically says, I have all the data I'm missing. It says, these are my tables. This is my timestamp values. This is my version. The server says, no, because your database version is out of date. Because part of that file I showed you has a version in it, which on the server says 2, but the client has 1, which means that a programmer updated the version on the server and the client wasn't updated yet. And he updates himself automatically because between the two of them, they can find out without human intervention that he's out of date based on just this one parameter alone. So he says, okay, you're out of date. Then he asks, can I have a new database? Or can I have the new database information, which is for version 2? And these are the parameters that needs to send. In this case, it might be an Android client. Android uses SQLite. He's going to send that Android client SQLite code so he can create his own database and replicate everything else. So response is, sure, here's version 2. And it is, like I said, it's actually SQL, which is a database query language. Now that the client is updated, he can re-request the API sync and get everything missing. So now he's on version 2. He has 3 tables instead of the 2 tables I had before. Everything is 0 because he has nothing. He's going to get everything right. And the response is, okay, everything. Those were the 2 biggest parts of the project, I would say. although there was much more going on behind the scenes, because it seems a little magical having one file and then you type one thing and you get all these clients. But in conclusion, the main goal of the project was to not have to repeat yourself every single time you needed to have the same application, which is actually a significant time. So I've reduced, on average, well, I can't even say, it depends on the client, but in this case, a typical client would be 1,000 to 3,000 lines of code, 4,000 lines of code. That turns into 15 lines of code in a configuration file that you can create multiple clients with without having to spend months on end having to learn all these other things. So I want to thank my advisor, Mr. Chiwade, and I think this is a good time to open it up for questions.
So is your stuff available for people to play with?
Yeah, it's actually on GitHub. If you want to go,
okay.
It's Coexist on GitHub. So, but it's in like 3 different repositories. So just because it's the right way to do things. It's, you have GitHub. You have Coexist, Coexist Android, Coexist Server. You know, other things too. Everything that's a separate component is in its own repository. But Google should help you.
Well, just go.
Yeah, that's good. Right.
Yeah. So what you were saying, this seems like it would be useful for any application that needs a cached copy of a database in terms of performance, because it's downloading the entire database
Yes.
basically to the device. How do you avoid collisions if, say, 2 users try to update the database with conflicting information in this model where you're downloading thing like a local copy of the database?
Yeah, so I guess that kind of goes into, this is called handling deletes, but it's really what happens every single time you make a request to the server. You request, you check all of these parameters, and the user ultimately in the end has the option of saying, if there's a conflict, I want to overwrite it. All these conflicts are based on pretty much the replace parameter, which is sent in creates, and also a deleted parameter, which is actually part of the table, like mod TS that we saw before. Every single one is marked either as deleted or not. So if you send something and Lucas sends something, they're both the exact same. Whoever gets there first gets there first, and whoever gets there second says that's already taken. Do you want to be able to overwrite it? And he can overwrite it if he wants to. So in that sense.
So does this require that the app is like an always-on kind of application? So in order to write, it needs to contact the database. It doesn't.
That is
have any
a separate issue that's dealing more with client implementation. Like in Android, it's or at least in my Android. If you can't get online, then it's stored locally until you can. So
Right.
it's really.
But in the event, say you're offline for a day and you make a lot of inserts to your application, and then when you try to sync it, it turns out there's a conflict with all of them. Does that?
Then one by one, you'll have to merge,
Okay.
if you will.
Yeah.
Those conflicts, yeah.
Sounds very painful.
Well, I mean, it depends. I mean, it is a handheld. I mean, if you do 1,000 handheld updates, then yeah, it's going to be unfortunate.
That's the way a lot of repositories, I mean.
If you were to do that with Git,
Code.
you'd have to do a similar thing.
Yeah.
Right. But that could be improved in the future. I think you kind of.
Yeah, I was going to ask, in your form generation, does it include error checking and trapping and reasonable error messages for people who type letters into fields that can only take a number and other stupid data entry stuff?
Yes. Big part of that is actually something I didn't show you, which is the metadata file, which hopefully doesn't look like a huge mess, but
That's where the other 4,000 lines of code is?
this one is only 80. I'm still 80 over 4,000. But yeah, so in this case, the fields here, if you can see that, every field has a label, a type, and a column. The column corresponds to the column in the table. And then we have a concept of types, of UI types, which map ultimately back to SQL types, but they help you filter input, and that's exactly what they're doing.
All right, I'm going to end the formal presentation here because I really don't want Anthony to fail.